Lesson 6.7, Graphing and Solving Quadratic Inequalities. Before we do this, we have to remember the main idea with graphing inequalities. If we have a greater than or a less than symbol, or less than and greater than symbol in this case, your lines will be dotted. If we have a less than or equal to or a greater than or equal to symbol, we're going to have a solid line. Now the fact that this is quadratic means it will not be linear, it's going to be curved. But we still have to decide if it's going to be solid or dotted, and if it's going to be shaded inside or outside. Now we know right away, just by looking at it, that we have a y-intercept of 2. It's going to open upward. If we look at this right here, we know it's going to be dotted, so that's not going to be like that. It's going to be like this. And we don't know exactly what it looks like right now, but if we get a graphing calculator out and plug that in, it'll look like this. So here's our equation. When we graph it, it'll look like this. So I'm going to sketch that here onto this picture, and it's going to be dotted. So looks like it went under and came back up. And again, it's a rough sketch, but so far so good. Now we have to decide, are we going to shade inside the bowl or inside the parabola or outside it? Same rules apply in terms of just checking something. Here we have 0, 0, so we check 0, 0. 0 is greater than 0 squared minus 0 plus 2. So is 0 greater than 2? That is false, so we will not shade outside, we will shade inside it. And this is one type of question that we'll have. The second type of question looks a little bit different. Notice, first of all, that we have a y involved in our quadratic inequality. In the next one, there is no y. Okay, so we're not going to graph it the same we would on the last question. Now it's just a question of, let's start out with this first, and then I'll get to that question. We go y equals, and we go x squared minus 4x plus 3, and we graph it. Now notice something here. We have the question, we have a parabola being greater than or equal to 0. Now let's look at a couple key things. We have a y-intercept of 3. It's going to open up. We're not concerning ourselves with dotted lines right now, but we are going to ask ourselves, when is this parabola, the parts of the parabola, when is it greater than 0? Now when I say greater than 0, that means it's going to be up here somewhere. This is less than 0 down here. This is greater than 0. So less than 0, greater than 0. Again, if I sketch it, right now I'm not concerned so much about solving it. We've done that. Looks like 1 and 3. 1 and 3 looks like the y-intercepts, and the vertex, I believe, is down here. If we graph it, when is that parabola? When is this parabola above the x-axis? It is this piece and this piece that we're talking about. So we're looking at it from here, for all the x values, from here and to the left would put the parabola above the x-axis, and here and to the right would put all the coordinates of the parabola above the x-axis. So our solution here would be for all the x values greater than 3 and all the x values less than 1. Next one, we graph this one. A couple things we notice. Y-intercept at 1. It's going to open downward. Again, there's no Y, so we're not looking for shading or anything like that. And they're asking, and I'm going to switch this around. I'm going to swing it around so it looks like this. Again, because I said greater than 0 is up here, less than 0 is down here. We graph that on our graphing calculator. We have negative 2x squared minus 6x plus 1. We graph it, and there we have it. Again, I'll sketch it. We have the y-intercept, looks like 1, 2, 3, negative 3, and 1, 2, 3, 4, 5. So I would guess about here and right in between. So that's going to look like this. It's not a V, of course. All right, now, when is that parabola greater than 0? When is it above the x-axis? And that is from here to here, the graph is above the x-axis. Now, if you look at your calculator and you trace it, you'll get about negative 3.16. Use our graphing calculator. And it's less than or equal to now, because that was the way it started, up to 0.16. Now this represents the places, or the x values, in which the parabola will be above the x-axis. That is by using our calculator. We could get our exact values by using the quadratic formula. That would also work. But we want to make sure we're clear that the solution to this question, where it's greater than or equal to 0, is between those two intercepts. I'm going to stop here, and I'll do the last two questions in part B.